Yeah, once again, good morning. So, so this is primarily for folks in and around Coimbatore who would like to, meet up and socialize and especially have a technical, community around Coimbatore. I think there are a lot of people working in this technology, but unlike other cities like Chennai and Bangalore, we have a limited opportunities to collaborate with community people and helping each other and all those stuff. So in that intent, and just give me a second. So with that intention, we just started this meetup 1.5 years ago. So every meetup we used to have a, of course, everything was in person previously. Now thanks to COVID and all online, and we have good to meet a lot of people from across the industry and even across the country. And one among them is Nagarajan with us today, and he's going to talk about, and he's a senior software engineer and Snapbiz. And as you all know, he's very much available at his Twitter handle. You can reach out to him for any questions related to front end. And on a different note, he's also a functional programming lover. If you like to talk about anything related to closure or functional, just reach out to him as well. Over to you, Nagarajan. And once again, welcome you all.
Yeah, thank you, Karthikeyan. Yeah, like Karthikeyan said, due to COVID, not only around the country, across the world, people are facing this issue. We just can't meet together in person. That's the problem. Uh, me, about me. Okay, I'm a full stack developer. I work primarily on both back end as well as front end. And this is my hobby. I also play harmonica. And I among the technologies I work with, JS is like one of my favorites, and this is my Twitter handle. Like Karthikeyan said, you can reach out to me. I will be available. And these are the two GitHub account I use. I mean, I started one for personal, the other one I started for work, but I could have had both the same. But yeah, I have two GitHub accounts. Both of them I'll have my projects. Whatever I could share, I will share. Okay. While I'm in originally I'm from Tamil Nadu. I've been in Bangalore for 4 or 5 years, and while I am in Bangalore, I would typical like this once in every month at least one or two meetups I will attend. That's like one of my favorite thing to do. Due to COVID, it couldn't, but it also brings the opportunity for me to address you guys from the another city. I'm really thankful for that. Yeah, all cloud has a silver linings. Okay, okay, move on. Today our topic is React JS for games. I'm not sure how many of you are already familiar with React JS. I think most people already at least heard about it and seen the typical React JS programs. Or so I would assume most of you are familiar with the React JS. Okay. But when I say games, I'm not talking about games like this. When you say games like a Counter Strike, 3D games, like not like this. I'm talking something in the similar. Just have like a small expectation. We are talking about games in the demo like this. Just takes so much time to load. Okay, so yeah. So this is a very unpolished, kind of like a very not very good looking demo I just created. Here we can control some angle. It's kind of like a gun or something like that. Launch something. It will launch some things, and this will not like, act like a physical object. So let's just see one more time the demo. Basically, these are very basic elements which you can include to create the game whatever you like. This is something, this kind of games I really like. Most of you are familiar with it. Okay. And so let's just see how I built this with the React or okay. Before we go into even the React or game, let's just talk about one thing. Imperative versus declarative. What is the actual difference? Say here is like a small meme. Imperative programming. What this means is, say you're asking your wife or somebody, stand up, walk 10 steps by 4 foot to the fridge, use your hands to open the door, get me the water, walk back 10 steps. Okay, if you say something like this to anybody, they will definitely shout at you. Do you think I'm like a fool? You have to say each and every step. But say in a normal world, what we typically say, get me a glass of cold water. And they will figure out how to go to the fridge, how to take a water, how to take, and to give it back to you. But that's like a different thing. For my wife, even if I say this, she will shout at me. But anyway, so this is like a simplification of what you mean by imperative versus declarative. In imperative, it's up to you to specify each and every step so that the programming, whatever the platform has to do its job, you have to say each and every instruction. You have to do this, do this, do this. Then it may not reflect what exactly you want. When you're reading the code, it's hard to read and hard to maintain. But in declarative world, you just say what is the things you need to happen as short as possible with the only necessary information, not too much information. Rest of the things, the framework or library has to figure out. So when we're talking about the frameworks, all the frameworks purpose is to follow our instruction and create something for us. For this, however the minimal of information, however whatever the easier way we can do it, that way we can do it. We can't say to the computer to put each and every dot to create a text like this. We simply say type frameworks with this font and this color, this thing, and the OS figure out how to type this in the screen. Similar thing, all the frameworks and libraries, interfaces has to the thing has to do things with the minimal information which we can manage. If we start to say each and everything, it's become hard for us to do our jobs properly. So React JS come in this category, basically a declarative framework. In the React world, all you say is these are the things that need to happen. You don't specify each and everything how it's supposed to happen. Let's just take an example here. Keep on clicking control. No, please bear with me. Even with the fast internet, it takes a few seconds to load. Okay, this is a very well-known example. A lot of you are already familiar with it, but just okay, just for the context, we'll go over anyway. We have here is a React application where we have a count. It's using a state, and you have a count and set count. Count is for the it's basically a getter. This is a setter, and here we have based on number of count we have that many box, and this is all JSX. These are not actually HTML, JSX, and JSX is like a very ergonomic way for the React for programmers to specify to React what we need on the screen. And this is familiar because it looks like exactly like HTML. We just write HTML and let screen, but whatever comes there. For example, say I want to, whenever increment, we increase the count, and based on the count, that many boxes we are creating, and we are simply showing the boxes. And if you here, if I decrement here, when it goes to 0, it disabled. That happens because we simply mentioned an attribute disabled equal to this becomes false. This becomes false when the count is more than 0. When 0, this disabled become true, then the disabled attribute is applied to the HTML. All these things happened very declaratively simply. We don't have to mention any of those things like a set attribute disabled or a get count, or for each count you create a DOM and append it, and you whenever the count changes you remove a DOM or remove everything and add. So all those things don't need to be mentioned. Just you give the you have a one state, and relation between the state and UI you mention in the form of a JSX or kind of a template. Now, React figures out how to do this DOM operations in the HTML with making use of virtual DOM and other stuff that you can read about if you need to know the backend. Okay. So that's the kind of framework React is. And so it makes our job easier for writing UIs. Like for example, when the decrement goes to disabled, we don't have to mention this specifically, and all these relations are done there. So, but same, this is the advantage of being a declarative framework. Now, the same things. Uh, why can't we? But writing games is not straightforward. Anytime you see a game code, any kind of games, it's not. It look really complicated. They will have their own game loop, and everything will be low level. There is a reason for it. For any kind of animations or games that is like a too much user interactive or anything screen this something. Simple fact is you have to be really really fast. That means you have to create like a 50 or 60 frames per second in a screen to look responsive. For example, this GIF animation you see, right? It's not that smooth compared to a video because these drawings are hand drawn and these are typically created by 20 to 30 frames per second, or even less than that, 15 frames per second. That's a reason this looks like a very like a, animation. You can clearly see it's not a video and it's very slow, kind of stutter in between. That so in order to create 60 frames per second means you have to 1 second has 1,000 milliseconds. So you have about 16 to 25 milliseconds for each frame you need to display in the screen. We are talking like a really, really like a apart from adding the DOM and apart from whatever you call you make to display the screen, you have to process whatever you want to process within this much time. It's not straightforward. Like you would have your own game logic and all the other stuffs you need to do. So this is not possible to do with the declarative systems normally, and particularly when you have like a React JS. How React JS works with the whole React JS application is like a virtual DOM. All the JSX you create will create a virtual elements. Not these are not it won't create right away HTML elements. First, it will create a virtual tree. On that tree, any kind of state update happens. For example, I'm on clicking, I'm setting the state count. So that means some kind of state update happened. Then uh, that state update happened at any level of tree, that like a upper level component or lower level component. So whenever a state update happens, from that level, it has to compare and check what are the things changed in all the lower levels. So for example, here it's happened only once, like this is like only in this level, but it won't stop here because from there a props might be passed all the way down to the tree. So it has to verify all these things. Now these are wasted uh, performance. Reacts React.js, so the virtual DOM definitely easier to write, but it's definitely not faster. Your application won't be faster than a normal application written using which does not use virtual DOM. But it does help basically a declarative thing. Look, you don't have to deal with all the lower level things, but it comes with the problem of this. Any kind of change happens, it has to go through the whole tree, and we can't have these kind of things happening when you're writing something performance sensitive as games. So React.js on its own definitely not suitable for your even like when you expect like a smooth animation or something like that, you can't animate that using just state or props. If you do that, you will have some problem like this performance problems. So what do? We need to have a declarative thing, but at the same time, we don't want to lose too much performance. Our game has to be fast enough. That's the important thing. You can always write the fastest to program using C++ and Wasm or any of those things, but a lot of times you don't have the budget or time for it. It's up to you have to make something fast enough that is acceptable enough to do. So I found a way to do that. So I started experimenting with the React low-level integrations like React refs using the DOM operations directly by React. I created a library so that I don't have to deal with. I still have to deal with all the lower level stuff, but that will be abstracted away. I don't have developers doesn't have to do that manually. Created a library to do that. Basically, React DOM box2 library. So this is a library which I think just need to click it. Okay. This is I released in npm. You can still check the React DOM box2d. If you search in Google, also it will come. Now, let's just take a small example of what this library can do. Okay. So um, I hope the screen is visible for everybody. If any of you have any issue with visibility or whatever, if you are unable to hear, please interrupt me in between so that we can make. Okay. So,
Yeah, sure.
thank you. Okay. Now, what I'm doing here is that whenever I click, a box is for box is like a falling, as you can see. It behaves with a similar kind of like its own physics thing. So what this library does is that it uses the box2d. Box2d is a well-known library. It's a very old library also. Keep on clicking control. It's a box2d is a well-known. It's a very old library. Some of you might have heard of it. Some of you not. I really like this library from the moment I saw it. Like probably during my college time, I saw it, and that time always I have to use it. It's also a very complicated library to use. This provides a basically this gives all the things. Box2D is a 2D physics engine for games. That's all. It's a 2D physics engine for games. This it's basically simulates physics, but it's like a special 2D physics. If you see here in this world, your screen is a 2D. Now all these rectangles have a weight. It has a length, it has a breadth, but it does not have thickness basically. So in its own virtual the 2D, it's a physics library which simulates the physics, and it's originally written in C++. Later, it's been ported to almost all the languages. Box2D Java is available, Box2D JavaScript, even JavaScript ports itself, there is about 5 or 6 port library versions is available. ActionScript, almost even Flutter, uh, almost any platform you can think of, Objective C, you can think there is a port of box2d available. This is the go-to library anybody uses for simple 2D physics engine for games, and it has like a special thing, continuous collision detection, and lot of things what you need in a typical games is available. So here, if you notice here, this is not even canvas. All these are HTML items. All these are HTML items. We'll just take inspect one of this. So that's the reason I named this library React DOM Box2D. Okay, I will select one of the item. I delete it. Yeah, see, all the effects are taking place. So let's just see the code which we use to achieve this one. This is using a library which I already created. So you can think of this is like a simple to do, but with a physics. You add boxes, remove boxes. This is written long before the hooks and other things came. You have, and you also can change the shape to circle. You can have circles also. And its physics simulation is not really accurate as a real world physics, but it is good enough to look realistic, and it has a good performance. And I'm talking about the 16 milliseconds. All those things are happening within 16 milliseconds only.
Okay.
Yeah. So select and delete it. Okay. Now clicking on this is these are normal HTML elements only. So you set up the state with the inputs and other stuff. Let us just see the code separately. Yeah. You start with the world. You say how big your physics world is. Height is 300, width is 320, and you give a class. This is going to be HTML element only. So you give a class name. You can style also class name. On click on clicking inside the world, this is this dot create item. So what create item does, it pushes an object to the basically it updates the items. This is like a long before the, you're not supposed to actually push mutate the object like this, but I did that. So it pushes like an object into the items. It has a size, restitution, basically bounciness, how much bounce it wants to have, shape, and ID, and starting position, all those things. Basically, wherever they click, from there they have to create an object. Now let's just look how you are making use of these items while rendering. In the render, like just like any React application, you create an item component with all these properties, and inside you just put like a normal HTML thing. You wrap with a normal HTML. On click, you do all those things. Now if you look at this item, yeah, this is nothing but an item, a higher order component, which is imported from the React box2 library. All you have to do is the item is that you can treat it as like any other object, but you just have to wrap your HTML element with that, and you have to mention the shape. What is the shape your object is, and width and height. Then, if you want, you can mention the left and top, the position, the initial position. It won't stay there itself. It will just, if it is a normal body, it will just fall down based on the gravity and other situations in the physics. So all you have to do is to make it simpler. Okay, let's just look a very even much more basic demo. This is also a demo. It's in the library. So okay, if you look at it, you can see clearly what's happening. You these are basically HTML, nothing special. These are basically HTML, and you can see that all your normal React components works. And the box, circle, you have a box 2D by default has some basic shapes, but box 2D React DOM box 2D at the moment it supposes only two shapes, circle and box. Okay, as long as you within the shape, you can create like this. You create the world with the necessary the gravity. You want the gravity to be downwards, so on the x direction no zero gravity, but in the y direction 9.8. That's like approximately same to the our world gravity. And you wrap it with a physics item with a default position left and top, and how much restitution is basically bounce. Say if I increase it to 0.9, yeah, it will bounce for a while. Yeah, that's for the item. Then so you have then you have, if you don't specify the shape, it will assume it's a box. You can specify the shape. And circle, see, you didn't even mention the size. Lot of times, if you as long as you are mentioning the size for the actual wrapped elements, it will assume the size of that wrapped element. So you can see, if you look at the styles, yes, you can see circle is height 100 pixel, with 100 pixel. That's the reason it's this one. Let's just take 150 pixels, or a smaller one, 90 pixel. I have to mention this both. Yeah, now the circle becomes smaller and behaves further. And apart from these basic properties, there is other properties like a density. How much density determines how much weight it has. So let's increase the size. This is a circle, right? Density. Now it will be circle will be heavy, not bounce much, but yeah, because it has a head dense, so it won't bounce that much even with this one. So at the very basic, it just wraps your HTML elements into the physical objects. Then the, you can also, apart from doing these things, you have other properties of physics like a rigid body physics, like a force. For example, here I'm creating an object with a force. It looks like a cannonball. So let's just look at how the code responsible for this. Okay. If you look at the cannonballs here, you can read through the cannonballs. Your item has one important property called initial force. That is, when it created, what is the force it need to be applied? Now the force is in the format of uh, vector. Basically, you need to give the force at x direction and y direction. This is some small mathematics tried with the experimented and found this is the thing that works. Because when you are launching here, if you see, you're creating a ball and applying the force in this direction. That means you need x this much amount of force and y this much amount of force. Then only the ball will move in this direction. So I'm calculating based on the angle we selected. I'm calculating how much force is needed at the x direction and how much force is needed at the y direction. And you can see at each time, yeah, force vector. This first one is x direction, then is the y direction. This much force is needed. If the angle is like this, very steep angle, then x direction will have more force and y direction will have less force. Yeah, you see here, x direction will have 150, and the y direction has a minus 44. So this you can use simple trigonometry mathematics to identify this thing. Uh, but after you identified, all you have to mention is that when you're making, you make with this force, and rest of the things are normal HTML React application where you use inputs to bind with a state and use the state variable whenever you want, and you modify the data, and based on the data, all the entities will be created, and all the forces and other things will be applied there. So apart from these things, collision detection is an important thing for any game. And you say what in the collision detection? When one object hits other object, it has to move away. I mean, that seems like a very basic thing. Apart from it has to do all those things. For example, here, it when it hits them, you have to identify, okay, when this object hits this object, I need to do something. So in this case, what we are doing, similar force at angle utility. Uh, what we are doing is when we have like here you have like a cannonballs we're generating based on the number of click you have a box. Now this is the box, the wall you see here, and the smiley is the ball you have. Then on the cannonballs, you have a callback on begin contact. This is something you can apply on this physics item on begin contact. That means when it start touching other object, you can get the event has a method called get others category. So what is category? In this case, each physics item can have a property called category that you can specify. Just somewhere mentioned. Yeah, class name. Category. Yeah, sorry, I forgot where I mentioned. A box has a category. If the metal property is passed, wall metal or else wall brick. The you can category is just with string reference, what kind of object it is, so that it can be later we can take. Smiley, if you look at it, you can apply on begin contact callback for any elements. So whenever this is like this is smiley on begin contact, if it hits the wall brick, you kill after 2 seconds. If it kills the if it hits against the wall metal, you kill in 1 second. So just see the currently you have a brick wall. If you want a metal wall, just need to say metal property true. Now this becomes a metal wall. Okay, I'm not sure it is visible. Let me just load it. Okay. Everybody can see here there is like a darker something is there, right? Now difference between the normal brick wall and metal wall is it has a higher density. If you just hit it, it won't fall down. But if you hit really fast enough, okay, it will eventually fall. Right away, it will be killed. But if it were um, normal one, if the metal were not there, there's a normal one. Just one hit, it will fall down, and it will take 2 seconds for the this to be killed. Okay, so all this logic is like as if you're writing a normal React application, but your components are powered by physics, actual to the realistical physics, for which you don't need to specify a lot of things. You just need to wrap it with. Does it sound familiar? Basically, I wanted to make similar experience with the React, but for the physics engine declarative. You don't specify you don't specify a lot of things. You just specify, okay, this is the things I need, and the rest it will be created automatically by the library. So to do the things. So you have the collision detection and other stuff here. Now, how many of you actually want to see how this is being implemented as a library, as a representative?
Yeah.
Okay, so most of you like let's just look into under the hood what exactly is happening. Okay, let's just take the GitHub repository. I'm not going to go through all the code, but important code, see what exactly I'm doing. Let's start with the world. Okay, this is the part where we need to create the world. This is like your if you notice, IBG has like a two important component: world and object, world and item. You start with the world, and any object that has to behave with the physics, you wrap it with the item. Only those are the two primary uh, components you have. So start with the world. Yeah, like I said, this is created really long back when this thing was not a people have started using the hooks yet. Now I really like hooks. I'm planning to rethink the hooks. Okay. So what I'm doing here is I can see these methods. These are all box to D methods. B2 world, B2 V2. All this thing starts with the bar. B2 is like box to D things. So I'm using a typical thing like on component constructor on. So I'm creating a new world, B2 world, and I'm taking these props like gravity, sleep scale factor, and all the other stuffs, and I'm supplying with the default whatever I think is a sensible default, so that when the beginner starts it, he doesn't want to. There's like a about like 50, 60 properties, possible properties is there. I don't want to overrule the beginners with all these options. So let's just start with the necessary properties with the defaults. Without gravity, you won't see anything happening. And gravity, you can change the direction also. Say, for example, here I say 0.9. If I say 0 minus 9.8, now all things will, as if it's like a going upside down. It's just trying to go upside down like a space. So that's a, it's not necessary always has to, things has to fall down. So depending upon the game, you can adjust the gravity and you have to, this thing. These are all the options we use for the box 2D. You can read in their documentation. enclosed true by default. So one thing, if you noticed, uh, you have a kind of like a boundary to the world. There is a wall created here, 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 four sides. Without these walls, what will happen is your object starts falling down and falling down, and it will go out of the screen eventually, and you don't know what's happening right away. So by default, we create the enclosure. If you don't need for some reason, you can remove that option basically. Enclosure thickness is 3 pixel thickness. Uh, then you have like other steps to make the box 2D work. Uh, Start with the important thing. Render physics. You have a this dot world that will be like a box 2D world. M dot body list. This is a function provided by this is a property provided by the box 2D library. You can list at any moment what are the physics bodies within this world. That's how like we can loop through it and get situation like you can update the properties and other stuff. Then this is where the physics loop. I'm using the request animation frame at each step at every 16 milliseconds. This runs. It will clear the forces and render physics and physics loop start. So what render physics does, you have to call this step. That it means the physics can run its simulation at this step. So render physics for each. There is a property called awake. If an object is sleep, you leave it as it is. If it is not awake, just leave it as it is. Then I'm looking for user data reference within the box2D object, and that reference has an actual DOM reference to the HTML element which we need. Then I'm trying to get the x and y position from the box2D object physics library and its angle. And based on that, I am updating the DOM position. Now, this is an important thing. Since we are updating the DOM, this is where we really have to be careful. Like I said, the 16 milliseconds, you can't take any risk because this is like a very hot loop. This, like I said, if this was fast enough, your program will be fast enough. But if this is a little bit slow, then your whole library and the whole games will be slow. So from canvas to DOM, from physics to canvas. Now, the biggest problem with working with the DOM is that DOM has a different coordinate. Uh, just increase the different coordinate system. DOM left, you have a left and top. Left 0 means here. Top 0 means here. Top 10 means here. So you have the coordinate with the origin here. But typically in the normal, when you have the computer coordinates, it will start from here, 0 here. So at y, x is coming from this direction and y going this direction. But DOM slightly different. X basically it's not called x, it's top coming from 0 to 100 like this in this direction, and y uh, the x is coming in the direction and y is coming from this direction. So that translation you need to do. And another thing with the physics is uh, we, we are talking about, like for example, this is like a some 100 pixel or something like that. You can't simulate with 100 pixel. Box 2D is created for real world objects. So each object has to be at least a meter or some like a few meters long, then only you can simulate properly. So that kind of calculation differences are happening here. And you figure out what is the left and top has to apply for this one. Then you apply translate. You use, important thing is you use the translate and rotate transformation. You never ever you update the property like left or top directly. What you do is you use properties like a translate, transform, rotate, so that your it won't cause the DOM reflow. Otherwise, it will cause the, if you try to update a left or top, no matter how fast you are doing, even if you do with the plain JS, your browser will stutter and it will cause a lot of CPU issues, because every time you update any position like width or height, even try to read these properties like offset width or offset height, it DOM has to stop and calculate each and every element's height, and it has to calculate the layout. That's going to be very really slow. That's the reason updating the DOM is really slow, people will say. But as long as you're sticking with these properties, you're kind of son, because these will take advantage of like a lot of advanced rasterization and other techniques. It doesn't causes the reflow. So I'm using the translate and rotate to update the I'm getting the rotation angle and all those things position from the physics library. I'm updating onto the actual elements. Set transform is just element style transform and apply this directly. So if you notice here, at any point I didn't use React state or React library, the React's internal reconciliation props or any of those things while I am updating at the each loop, because you can make use of React for normal things, but the moment you do it for every frame, it will slow down. So all these things are done lower level to avoid the reconciliation problem. If we do this ourselves, then what's the point of using React? Yeah, that's as long as your whatever the doing operation is abstracted away from as like a separate library or utility. You when you're writing a game, you write like a nice like this. You don't care about all these internal things, frame updation, all those things. So it gives a real benefit. At the same time, we are taking care of the performance by using a low library which takes care of all these things without using the React mechanisms. So let's just look into the physics object, the second small thing. We're not going to look into the whole thing. Box to the object. How this component is written. This is like a so this is like a kind of like complicated because box 2D has to create something called fixtures to create each and every. So this happens for the first time. Like so all these normal things like height, width, all those things are happening first times. We don't want to do this every time. We just need to do at the time of the initialization based on the physics and all those things. Get client rectangles and all these methods are from the DOM element, which will give the exact position, what is the size from the, it will calculate based on how it's rendered in the screen. Based on that, I am actually creating the physics objects, and I'm using that references to update with the user data. I can get the actual DOM. Actual DOM references is being used as a ref this.el, and that reference React references that's being updated to the user data. You remember that is a user data. We are DOM this.el. So if you look at it, each object would have a reference to physics object, and each component will have a reference to its physics object, and each uh, physics object will have a reference to its DOM. So whenever something changes in the physics, we update the DOM directly. And whenever something changes in the React, we update the physics, and the physics will update the DOM. So this is the way we are handling all these physics interactions without dealing with our own without basically all these are hidden away, abstracted away from the normal user. So we have a nice developer experience, and so that's the advantage of using this library. And many would say, why even use DOM specifically? Typically, when we say games, a lot of people have already heard about it. Canvas, WebGL, and the other stuff you need to use because that's how you are supposed to write games. There is a reason for it. So, um, like most people are familiar with the. How many people have used WebGL? Let's quickly look in the chat. Say a few seconds.
Yeah, I think I have used 3JS and
3G. Okay.
Babylon, I think.
Okay, Babylon. Okay, yeah, 3D for the 3D things.
Yeah, 3D. Yeah.
Yeah. So yeah, typically for 3D and high performance, we use the WebGL. That is the reason for it. We don't use the DOM to all those things. Even for a 2D, it makes sense to use WebGL. The reason is like let's take this like a good, really good video.
All right, I introduced to you
So
Leonardo.
I'm not sure. Can you guys hear the audio? If I play the video here,
Yes, yes, we can.
yeah, you can hear the audio. Okay.
And he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up. Ladies and gentlemen,
Leonardo 2.0.
when we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over. Thank you.
Look, I think we all enjoyed the video. I'm sorry to have put a video because no matter how hard I try, I won't be able to explain better than that. Difference between a CPU and GPU. CPU by its nature will work one instruction set at a time. It will be really fast. It can switch between instruction, but it will appear like as if it's doing parallel processing, but at most it can do one or two things at a time. Even if it's a hyper threading, it just one at a time only CPU can work. But GPU is optimized for the graphical purposes, specifically for painting your screen, calculating what the data you need to come into the screen. So GPU can do a lot within few seconds because it can do all these things parallelly. It is optimized for that purpose. As you can see, this CPU machine is very small, but GPU machine is quite big. It has to be specified with all those tanks and other stuff. And that is the reason for a good game you need a good graphics card. But there is also a disadvantages with going with the GPU because all our programs like JavaScript and all the Python, all our programs run on CPU only. Those are not designed to run on GPU, and also GPU is not designed to run this kind of a general purpose programming language. GPU has its own language called shared GLSL and other just general purpose like a shader language and other stuff it has. And most of the time we just try to upload the pictures and we'll just show up use the manipulate the pictures in GPU. We don't have that division elements, accessibility and all those things, on click events and all not by default available on GPU. You can't specifically create a rectangle and say on click of this rectangle I need to do some action. You can't do that because your JavaScript is not running on GPUs. It's only deal with what to display on the screen. It doesn't deal with the user input. All those things has to be artificially integrated. And there have been a Flutter is doing that way only. Basically, their whole stack is completely using the GPU. That's the reason it's faster deploying. So, but GPU definitely has an advantage when you're dealing with when you're writing programs, writing games. So, React and along with the disadvantages. So I've been experimenting with this one Pixie.js. Pixie.js is a library. Pixie.js is a library. Some of you are familiar with it. There's a really nice library if you want to write a 2D games. It can do, I mean, a lot of what you're going to see will be shader language, not JS. But at the very basic, it can make use of GPU properly. It's a kind of fastest 2D WebGL library available there. So it can have a simple example. Let's just take a very simple example from Pixie. If you're using Pixie on your own, Yeah. So let's see how this is written. Yeah, this is a very bare minimum without using React or any of those things, just using Pixie. You create a Pixie application and you document up inside app.view that will create a canvas or WebGL. Then you create a container and you create a texture. This is a texture is different in a GPU. So because whenever you call like this, it uploads your images to your graphics card. From that point onwards, you just send the instruction. You show the image here, show the image, show the image here. So there's a kind of optimization it will do, and it will just use a normal loop, and you create the container or a child sprite. All these are terminologies are there. Then you ticker. This is like at every frame what you need to do. At every frame, you just change the rotation to decrease the rotation with the delta and something like how much time passed delta into 0.01 rotation a little bit so that it will look smooth. So all this is done by the canvas. Now, if you look at their API, it's quite imperative. It is because it has to be, because when you're writing games, typically their APIs tend to be like this so that they don't lose any ounce of performance. You're going to trade off a little bit of performance for our convenience. So I've been experimenting with the presentation. Yeah, this is something, another unpolished demo. Just look at the demo first, then we look at the code. Code sandbox is quite slow. Okay, yeah. If you see here, it's slightly. I think everybody can see there is like a pink color car, pink color kind of like a block with the two wheels, and there is some few steps is there. You can go stop. It's kidded. It's kidded. Before it's. I'm not sure people can see it. If you look at here, it's these are actual wheels. These are actual wheels, which will. This is a kind of like a. These are actual wheels, and these are an actual physical object. Connection is there, and I haven't yet released this as a library. I'm still working on it. But if you can look at this whole project, I can type that library. I'm using the Pixie library only, and I'm using the same concept: physics object, physics world, and I'm also using the React. And if you look at that, let's just take one of the here. This is like a normal physics world, and you have a car is a we have a car which is car is a component. Now just see what is the component as like a car has a speed that is part kind of like a state, and I'm using use hotkeys. Use hotkeys is like a library which will contains on arrow right, on arrow left what you're supposed to do. Okay, then basically a shortcut library setting the speed to this one, and here is I am creating a reference for two references: front wheel ref and back wheel ref, these two wheels. Then I'm creating a reference for this body, this sprinkler thing. Then I'm using a hook called use joint. Joint is a concept provided by the box 2D library. These kind of things are easy to do with canvas and other stuff. I'm passing this one. This joint should have motor, and motor speed is whatever the speed I'm getting from the state, and enable then you have like a motor torque joint one ref. This is like a motor torque. This is the speed I need. Let's just reduce the reduce the torque, maybe 3 or 2, and the speed we can reduce the speed, like how much speed is applied. 360. I mean, to the wheels to turn, it has to rotate 360-degree first, though. So it has like a 15. This one is 5, and here also 5. Now it will go slightly slowly. Okay. Then you have like a creating a joint with anchors front wheel ref and body, and anchor one. Where's the anchor one? Yeah, anchor is nothing but which position this joint has to connect with the body. You have x0, y0. That is, like I said, the canvas has a coordinate system that starts from the bottom left. This is y, this is x. Now this is a local coordinate within the object. In the object body 1, I have to x0, y0, and the second body minus 40 to 15. So in that position, I need the wheel to be jointed with the joint one drive, front wheel ref and body ref. Now, if it's enabled, the motor is enabled on only front wheel or back wheel. Now the second joint, joint 2 ref, enable motor false, anchors 2. Now this would be your position again, like a body position comes second because the body is like a ref 1. Ref 2 is the back wheel ref. So I created it. Now I create another fragment. You have a wheel component and ref, and I'm applying ref here, and x, y, and x and y. It's a default position, but it doesn't matter. And density of the wheels, how thick the wheel has to be. Then physics object, violet, green. Okay, these are all other objects like these blocks. Some of them are stationary. Like for example, this black one. Sorry, intensity, body of violet, green. Okay, it's mentioned somewhere. So these are other things. Okay, on clicking go, it has to go. On clicking reverse, these are all normal buttons. If you so this is currently what I am practicing. Even though this is canvas, you can just put a HTML button. It will just come outside the canvas. All your objects. You can have the button click, and based on that, you can have your game. So this is like a compromise. You can't add on click within the game, but you can have HTML elements outside the game like this. So on clicking the stop, you set the speed to 0, and other stuff you set the speed to this one. Okay, let's just use the arrow. Now it's okay, just to open this one. Sorry. Okay. Now it will be like it will become slowly, but it will, because we reduce the speed now. But this force is applied and torque is there, then it's keep on going. It's a motor. So these like a higher level physics concept on put on top of the canvas, so that your game will have good performance, and also you can use the best parts of React, and you have a decent performance out of it, good developer experience. And this is all fully canvas, no HTML elements. If you prefer to use HTML elements, the advantage of HTML elements is you can style it with just CSS. These are all CSS. You can have the style CSS, can change whatever you want. So the background is black. I want green, blue. Yeah, now the background is blue. I want the balls to be yellow. All you have to do is make the CSS change. Almost everybody will be familiar of it. So you can create a pretty decent looking game very quickly. Then compare to this, where you everything, even like it's not easy for me to even to this looks much uglier, and it's hard. You need to create these images, assets to make use of anything, but it does have some advantage. You can use like make use of sprites and other stuffs to make like a nice animation. I haven't yet worked on it, so that is the advantage of using the canvas, WebGL, and other stuff. So uh, anybody have any doubt regarding, I mean, I talked like a really long time, so anybody has any doubt so far, please feel free to ask, because we have time.
Yeah, if anyone have any doubt, you can use the
Any
chat.
question?
Yeah.
Yeah. So So, not anyone? And I'm not seeing any chat messages. So let me just continue with the summarization of whatever I talked about. Okay. So I really like declarative programming, and as you mentioned, the reason I like functional programming is because they tend to be more declarative. But there is a reason why the declarative programming is not typically used for writing games. There are some entity-based systems, but it's not easy because most of them are quite complicated. Because when you have a declarative system, you give very, very minimal information. That means you let the framework or library to take care of rest of the things which you don't control. That sometimes is not optimal. For absolute performance, you have to do a lot of hacks that you can't do with the declarative thing. So, and particularly React is not suitable if you are using as it is, like for normal uh, application or for normal games. But you using like hacks like a ref, and you updating the ref DOM properties or the actual native properties directly, you can take advantage of the React without sacrificing the performance. I mean, still you are losing little bit performance, but that is very minimal, and it is well worth the gain you are getting out of it. So then we talked about the library which we use. It's a DOM library primarily, and whether you want to take the DOM or WebGL for your game, it's up to you. But WebGL will give like a full performance. It's like absolute performance. Even with all the tricks we use, transform and other stuff in the DOM, it's going to be at least twice as slow as the WebGL one. So WebGL has like a lot of things easier and smoother, and you can do a lot of stuffs with WebGL, which you can't really do with the DOM. So, but it's easy to get started with the DOM, and you can make like okay looking tiny projects quickly compared to WebGL. WebGL because it has too much asset work is involved. So, if you have any doubt regarding this or even the React renderers, because if you have any doubt regarding the React and Canvas, any of these things, please feel free to ask that now.
Hey, actually, I have one question. It may not, it may be a little out of context.
Okay.
But yeah, like, do you have any idea what diffing algorithm is used for the React reconciliation, the tree comparison?
Yeah, the React people have already mentioned
Okay.
their diffing. They said the diffing algorithm doesn't make much difference. You can have like a fastest diffing algorithm, but still your most the performance losing is not that part for the normal view application. And in another way, no matter how fast the diffing algorithm is, just the process of diffing the whole tree, that is slow enough if you do it really a lot of times. So the algorithm which they use is currently they use like a really complicated data structure called React fibers. Fibers is like a linked list kind of thing,
Okay.
so that they're able to use the asynchronous rendering, so that our concurrent rendering, what they call is a concurrent rendering, they still
Yeah,
haven't released
this.
it, they are just experimenting. So what that concurrent rendering needs is that any kind of a change, like for example, at the very high level, very simplification, any kind of state or a prop, I mean any kind of state change happens at any level. That's the reason only proper state change, that only they can detect. So when that kind of things happens at any level,
Okay.
all the tree downwards has to be and compared, and based on that they have to apply the diffs, like if there is any diff is there or not, just checking. That is
Okay.
reconciliation. So
Yeah,
that,
and they have also some delay manually inserted, right? So it doesn't depend much on the diffing. Yeah, correct. Yeah.
yeah, that is those they're calling it heuristics. So for example, when you're
Hmm.
setting a state like a very really fast, like 100 or 1,000 times per second,
Okay.
they will wait for a few milliseconds, then they will batch
Okay.
all together.
Yeah, kind of debouncing. Yeah.
Yeah, and also apart from that, they are doing but all these patterns is suitable for the UI. If you
Okay.
try to do these operations while you're running like a games or stock application,
Yeah, yeah.
you just lose all the things. But yeah, those are the things optimized for the towards the UI application, so that no matter whatever you do, the screen doesn't freeze. It'll update a little bit slower, but eventually it'll update everything, and your screen will be responsive for all the things. So in order to do that, they have the stack. That means current as if the synchronous rendering means if you change some state here, it has
Okay.
to finish reconciliation and re-rendering from
Yeah,
all the
every
whole
OHP
tree.
level. Yeah.
Yeah. So, but with the current one, they can start reconciling if it if going to this level takes more than 16 milliseconds or 15 milliseconds, they will stop
Okay.
at this point. Whatever they did, they will store it. They will come back for the next frame. So eventually
Okay.
they will finish it. So that kind of stacks they have currently.
And one more thing, for this
Yeah.
game, we are having multiple events fired, right? Like same time.
Yes.
Uh, yeah. So, like, how can we leverage RxJS in this? Because it is
RxJS,
like RxJS, reactive. That,
RxJS. Oh, RxJS.
okay. So it will
Uh,
be helpful if we can make the events as observable, or it is similar, or kind of.
okay, the thing with RxJS, it kind of works like a push-based system.
Yeah.
Typically, push-based system. You trigger some event or you listen for some event. When it
Yeah.
happens, you handle it like this. But particularly React, it's a pull-based system. So React also has something called render loop. So at each loop, it will check what other changes has to be done, and it will look at the events. Then it will do one by one. So RxJS mechanism and this React.js mechanism is kind of odds with each other. But my advice, particularly for games, is that even RxJS is not fast enough for games. When you're dealing
Okay.
with the games, particularly like this, you just go as low level as possible to providing the
Okay.
minimal developer experience. So it's better to write these wrappers yourself instead of dealing with
Okay.
any external library. Those libraries are meant for UI pattern, but not like a games pattern.
Okay. Cool. It was really nice talk. And can you drop this link in this chart somewhere? It will be
Yeah, yeah,
helpful
yeah,
with the
yeah, yeah,
slides.
yeah. Yeah, I will drop all the links, including this one. Okay.
Thank you.
Yeah,
It was
you'll
really
also give
nice.
me those later
And
session.
I will also drop this library also, just in case. Where is it? Okay, I will just search. I mean, these libraries are linked in within the links are provided within the presentation, but just in case this I created long back. I'm in the process of writing this for the Canva Pixie.js so that we'll have like an actual this thing. Okay. So any other questions? Any other question is? And also, just one thing I wanted to point out. For the canvas, I have experience mostly this like a for canvas based one. Not this. When you're dealing with a thing like canvas, React doesn't have a canvas renderer. You have something called React reconciler, something you can write yourself, and you can that is also provide. I typically write a lot of times. I'll just try. This is my first attempt. React down physics. I use matter.js different physics library. So okay, repositories. React reconciler. This is a documentation and this is like example. You can try creating yourself your own React renderer. So this is like a file renderer that executes in the Node.js. Basically, when you have something like this, like a completely imperative API, you want to adapt this for the React. You have like a DOM kind of thing, add child, then append child. then remove child, these kind of call you have, then you have something like a DOM imperative API. React is suitable for this if you use React reconciler. Let me just have an example. Yeah, I think this will be fine. It's like a very simple example. This is not a good one. I tried to use the plain canvas for with React. Yeah, I'm using a 2JS library. If you see here, I click it. So I used a normal React JSX, and I'm using like a separate reconciler, canvas renderer. If you look at the canvas renderer, it's using some proper library called React reconciler. That basically you can create your own uh, adapter or React adapter for your own library. That is whatever the library you can think of as like an object-oriented API. You can use React reconciler to convert this API into a React one, so that you can integrate these other canvas libraries with your React projects easily, so that you end up with something. The canvas renderer, render app 2. This is like a complete custom renderer. This is like a normal application, but it has like a separate renderer, not normal React DOM renderer. Just like React DOM, React Native, you can create your own renderer, and you can use this to your app, whatever the layer you have, graphics layer, you can convert this to canvas. That's the reason we have a React wrapper for AR and augmented reality, then your 3D glasses and all the other stuffs. You can use React to use the platforms. Basically, it's a glue code for your imperative code, so that when you're writing, you will write a declarative code, but internally the React will call all your imperative API for you. So that's it. Okay. So any questions still remaining? Let me just drop the link for this also.
Nagaraj, maybe you can share in the meetup page itself so that it will be available for everyone.
Yeah, I will
Chat
share
is
all
just,
these links to the.
yeah. This is just temporal, right?
Okay.
The
Okay.
session
Thank you.
people will know. Awesome. So anybody have any other question? Okay, I think people are busy with the processing your information.
Okay, that's. I guess thank you. Like I said, it's been a great opportunity talking to you guys.
Yeah, sure, Nagaraj. So before that, if you don't mind, can we take a photos? I
Photo?
would encourage everyone to come on video so that we can take
Okay.
photo.
So let me just start the video. I think I'm not sure how do I look. Yeah. Where is the screen? Where is the screen? I think I have to. I'm not
Okay,
seeing
I'm not
myself.
sure why I'm not able to. I think
Yeah.
Just give me a second.
Just correct me.
Ravi, can I take or else you can?
Yeah, I can do that. Just a second. So anybody else? Can you guys enable your videos? Others? First of all, I can't enable my own. Just give me a second. Okay. Yeah, so guys, just try a start video session, so it should be fine, I guess. Anyways, yeah, done.
Okay.
So once again, thank you so much for your time with us, Nagarajan. So it's been
Yeah.
really a great pleasure to having you,
Okay.
and definitely, we would like to host you soon. Maybe next time, maybe another boot camp or workshop or so, something like that.
Okay. Definitely.
Yeah, thanks for being generous,
Um,
and yeah, happy weekend.
yeah. Thank you, guys. Thank you, guys. Yeah. Nice.
Cool.
Next time again.
So
Okay.
others,
Okay. Guys.
yeah,
I think there is a call coming to me. Yeah. Let me just need to take the call. Thank you, guys. Yeah. Anyway, I will
yeah,
post all these informations in the meetup comments in short. Okay.
cool. Thank you.
Okay.
So guys, thank you so much once again. So we have another speaker coming up next in 5 minutes. So before that, I would appreciate all our sponsors, and I would really like to mention them. So we started very in a hurry in the morning. So we are being sponsored by Trust Trace, so who happen to be my employer as well. So we also being and we also have been sponsored by JetBrains, as you all know. We used to have a referral on every meetup. So that we pick two participants and we'll offer them a 1 year subscription by JetBrains. So which is you can avail it for any other tool, any of the JetBrains tool for a year. Okay, so the thing is, the Dinesh who is taking care of that Rafael is currently he's in a personal emergency, and I also tried to reach the JetBrains guys, and I think we need a few more days to get back from them. So this time, please bear with us. I think it will take another week for to get dispatch the licenses. Anyways, as you all know, we are very much available in the Telegram group. So please feel free to ask around there if you have any questions or if you have any suggestions. Please post it there. And we do have some. Plan of having a, I mean, like, we also welcome volunteers and contributors for the community as well. So it's been a quite a while, and um, just give me a second. Am I audible, guys?
Yes, Karthi, it's slightly echoing.
Okay, is it any better now?
Yeah.
Okay, my bad. So as I was saying, we are also looking for volunteers for this group. So this group is being, I think you guys may not aware, and we have been working hard in terms of a social media reach out and speaker relationship, and also are in hosting these sessions and preparing the whatever the Rafael or again, like the feedback forms from the team and everything. Okay, so we have a lot of other options are going. Again, it's not by someone specifically. We really hate that not, authority in this group. We want this to be driven by community. So we would really encourage all of you to get started with this and participate in all these activities as well. Okay, so without further ado, and I will hand over this session to Pandian. Pandian Murugan. He's going to present his talk on Angular internalization. So he's from Coveco. I guess many of you would have seen him over, in the Twitter and LinkedIn. Over to you, Pandian. Just let me know whether you can share your screen or not.
Um, hi, Sanan, and hi, everybody. Is my voice clear? So I'm just
Yes,
confirming.
Pandian, we can hear
Yes,
you.
Pandian.
Okay, I'm just starting the video for a few seconds. So I'll stop it after that. So since JetBrain is one of our sponsor, actually I was wearing a JetBrain t-shirt only today. So hope you can see the logo or not. I'm not sure.
Yeah, JetBrains
So,
would be, yeah, they'll be
yeah,
really happy
so
to see that.
yeah, so this is like one of the t-shirt I won in a contest run by JetBrain. So actually, I didn't know that we are the sponsors, so just eventually happened. So
Wow.
jump into the session. Like, let me share the screen and let me know once you could see the. Sarwan, can you please enable the screen sharing option for me? Like,
Yeah, sure, sir.
just
Yeah, just give me a second, Pandian. Yeah.
Sure.
I'll just make you as a host for now. Probably you can um, start sharing your screen, then I'll
Yeah.
reclaim.
Yeah, I just got it. Thank you.
Awesome.
So,
Yeah, we can see your screen now. Awesome.
okay, it's PowerPoint, right?
Yeah.
Okay, okay. Well, let me start the thing. So, I guess some of the people might already have Angular experience or like a front end basically. So we can, what we are going to see today is like how Angular is supporting the internationalization option as well as the localization option with their own packages. In the past, it has been done by third-party plugins or libraries. So Angular took its effort to bring this feature inside the Angular itself from Angular 9 aggressively. So today it's going to be a session how their first step has been made for the internationalization with Angular. So basically, it's going to discuss about the package at Angular slash localize. So basically, I will just go slide one by one and switch that to code. Like I already have a set of code. We'll just explain the few points we need to know about the localization. So I'll be switching between the windows here and there. So if you have any troubles with seeing it, just unmute yourself or just leave a message in the chat. Okay, so let's go to slide one. So when the internationalization happen or like localization happen is like you are working on an enterprise application or like you are working on a web application which will be viewed by a different set of users or customers in different countries or geographies. So whatever it is, like internationalization is process of designing and preparing your apps used in different language. For example, in India itself, like we have a lot of official language. Uh, Right. So basically, we have English as a common tool to share information. Like we need to focus on like a localized literature. For example, if in Tamil Nadu, we need to show the languages in Tamil, where some other places we need to show it in Telugu, Kannada, Marathi. So those kind of things we need to address to make the user more comfortable using a website or a application. So localization is another thing like. So first one is like internationalization based on the person's language or or it's a familiar or a local language. We need to focus on those process in designing the application. Next one is localization. In India, we will be having different kind of date format. In another place, it will be having a different date format. Those kind of local based process of translating or changing the view part is called localization. So this basically in the overall picture, it is like internationalization. So localization is something dig deeper and have another submodel. So internationalization in Angular. So basically, what are the various places we need to do this internationalization while displaying it? It can be a displaying dates or like a number format. We will be having some separator, like 1,000 separator, those kind of things in our country. In another country, it will be different. Like showing the currency details, like it will be INR for us. It will be USD for another country. So those kind of things are called internationalization. Like, and also we need to provide a support as the particular country is not able to view the language. We need to provide a fallback. Those kind of things comes as a bundle as a internationalization. So you could see this link, right? So this is the link of official documentation of Angular. So after Angular 9, they had pretty much updated this process. So you could see few things here, like how what is the basic things we need to address, or the various basic operations need to done as a part of internationalization. And they have mentioned like what are the prerequisites, like Angular CLI or XML related translation files. We will see those informations in our session today. So basically, this is like a quick step. So main focus is like this at Angular slash localize package. Actually, earlier it was like an undocumented feature or something when the Angular 9 was released, but after that they had updated the documentation and it's pretty much covered the basic functionalities in this documentation. So let's get back to the slides. So this is comes in Anglo 9 or Anglo 10. It's getting a little bit popular, or like people are just exploring. Still, it's not a full-fledged feature or something. So this is something getting developed on every releases. Before Anglo 9, how people had achieved this. So this slide explains that, what are the popular plugins. So I myself worked in various projects, started from Anglo 1, Anglo 2, those kind of things. Anglo 1 is completely pretty much different compared to the current Anglo frameworks or things. Anglo 2, I had worked in some other projects. So that time, I myself used these plugins for translation or changing the text based on the locales. Basically, when I come to the word local is something like mentioning the language. If it is a English, the local keyword will be en. If it is a French, it will be fr. So those kind of shortcuts based on that browser language or country language will be translating the text, or we will be providing the preset text. For example, we will be showing some warning message or error message. So that warning message will be a static text that needs to be translated, or having a different set of pre-defined texts in French to support the French customer. So those kind of things. In early days, it was done using these popular plugins, NGX Translate and Anglo Translate. So those were the histories or stories behind this localization. So how we can get started with Angular localized package with our current codes. So some of you might have already know, Anglo CLI will help you to set up the base code, or the minimal hello world kind of code. So all you can do is implement your or install your Anglo localized package with the help of this command ng add at anglo/localize. When we do it, what Anglo CLI will do is it will make an entry in a polyfill.ts. Once it is successfully installed, it will add the following line: import anglo/localize/init in the boilerplate code we have in our Anglo CLI default code or boilerplate code we have. So it will look something like this. So let me show a place how it will look like. I'll go to the code I already have. So ignore all the codes. I'm just showing what the changes will look like. Let me show the anglo.json. So this will be the place we will be configuring the internationalization files and the various things. So before that, I will show the polyfill.ts. So this were the line I was talking about, import at Angular. So let me try to zoom. I'm not sure where zoom is all. Okay, so this is the same text I showed there. What it will do is it will load the localized package and init it based on the configuration we had provided in the anglo.json. I will show the anglo.json file. So what anglo.json file will have is it will have the list of locales we have configured within our project. First step, the very first step will be targeting the files. So this is like a XLF. It is like a translation file. It will looks like a XML format. I will show the file thing. So the syntax will be IL810. So it is a short form of internationalization. And inside that we will be having locales. After that, I just configured two languages. First one is French. Second one is I just provided some random text like a TM for Tamil. So I think we will have another option when we are configuring the production things, and in the package this thing, we have to configure the locales again, just to make sure when we are running the application, we need to pass this code as a build process or serving the application. So I just configure another code here, and we'll be eventually having the all part of codes we will be having build process, we'll be having serve application. So those configurations needs to be added. So let me show the VS code. So I just opened the code here. So the entire Anglo JSON will looks like this. As I said, it will be having internationalization.
Frontend.
Yeah.
Yeah, go on. I just wanted to ask one question. Sorry
Yeah.
to interrupt. So is it
Sure.
like we have to, the target bill has to be on the local specific?
You mean this one, right?
Yeah.
So basically, by default, it will have the order of the packages we have. So we'll be having a default language. So if you want to build a different thing, like for French language or Tamil, we need to build those. We need to configure those systems, like build system. By default, it will be like a build kind of browser target only. So what it will do is like usually what we'll do, we will, if you want to build a project, we will do ng build. So if you want to build a French based language project, we need to pass like a ng build hyphen configuration equal to French. So we will be passing the language code and
When
the
you do
packages.
so, yeah, sorry to interrupt again. So when you do so,
No,
right, so it is just only French specific build, or like it still can support EM or TM in this case?
no. Right now, what we have is like we will have the language specific build only. So we ourselves
Okay.
need to switch between the packages and the languages in the current implementation.
Yeah, makes sense.
But
Please go on.
but NGX translate those kind of things. What it will do is like it will just translate the text in the runtime. So I will show the how the package will build and all. I will show it.
Yeah, sure.
Okay, so this will be the language like translation package. So what I have here is like I'll just open the French text. So what I have is like if the source text is Anglo-localize, convert it to Bonjour. So this is where the browser target will take a look. So I'll show a TypeScript file. Here you could see we have a new syntax called dollar localize. So it will be like a normal, if I remove it, it will look like normal title equal to, I'm just providing some text, Angular localize demo. If I put dollar localize, if I specifically pass some language in the build process, what this dot localize will do is like based on language. If the language is FR, which is French, it will look for this file and see match the text Angular localize and take this particular target from this, or it will have this unit ID. Basically, each and every text which is mentioned with the dollar localize will have this unit ID, and this is one of the format we'll be having as a XML to do those things. So let me go back to a slide so that I will show just the same words I had mentioned. So as I mentioned, this dollar localize is the main option to mention that this particular text needs to be translated or like picked in a different language. So this is again the format I had mentioned. So these are the syntax I was talking about. Like if you want to serve an application in different language, you need to pass the local code here. So let's see, like I'll just run this application. So right now we have this Angular localized demo in the app.component.ts. I ignore just all those things since I just used that title somewhere, right? Okay, we will just see in the UI itself. So what I'm doing is I'm just serving the application. Right now, I'm not passing any local code or the configuration code we had mentioned. What it will do is like it will take the default version and show it to us. So by default, I just having the text like Angular localization demo. Let's see whether it's getting showed. Okay, the build is a little bit fast. So here the package is here. So I'll just refresh. So the UI, this is where the text is displaying Angular localized demo. So what I'm going to do is now go back to my French listing. I'm just making it as Angular localized demo. So it will match the source text and convert it to the target text. Now I need to stop build and mention hyphen configuration equal to FR. So what it will do is like it will match the localized text and will provide us from the XLF file, which is like a XML translation file something. So you could see like it just refreshed before we switch the tab. So now it's showing the content from a different file, like the French file. It took the values from that French file. So next question will be like we have something like this, and whether we need to put all the sources like this and target how to like do it in a dynamically. So those kind of things are getting developed now. Only this like a very starting stage of the package is in very starting stage now. Like I'll go to the documentation here. Like they had even support these kind of format. Instead of a dollar localized, you can mention I18N as the HTML this thing itself. What it will have is like we go to this place. Just zoom out a little bit. Where this welcome is there. Okay, this welcome is here. I'll just put hello, I will make. So at the moment, at the IL like internationalization HTML, it's showing no translation found for this particular ID. So what it means is like we tried to load the internationalization from French, but it couldn't found any information in this particular file. So what it will do is like so let's see, like I'm just duplicating this thing and copying this ID from here. So this is one of the like problem this package currently having is like we can't able to get this ID at first place. So we need to like see in the build process. After that, we'll see in the warning and getting this ID. So that's the one this thing. Hello, let's see whether it works. So you could see still we're having some problems. So basically, they are trying to address it with some static IDs. So if you are having some internationalization here, they are providing some option to provide ID like this. So in this place, we will be having the option to provide some static ID like some words we can provide like home dot greeting. So when I put fresh builder, we could able to see here like hello French is coming. So if I switch to another English version or something, it will just show hello that internationalization IL18. So when we are going by HTML internationalization or like when we are doing in a TypeScript, we have to do this thing as a manual right now. And next thing they are working on is like providing the this kind of form greeting. Let me show this. I have it. So basically, they are working on this providing the static ID. If you provide a static ID like a home dot greeting, this is like declaring a variable name in a type or something like that. So you need to provide this thing here and configure the same in the like in the format we have this ID. So here it will be like a home dot greeting something like that. So this is one of the thing. So next thing I just I guess most of our people's from Tamil Nadu or like people know Tamil. So just will run a Tamil local. I just created. Basically, I think it will provide some information.
On a different note, it's TA for Tamil, right?
Yeah, I just configured with some random text.
Okay. Yeah. Okay. Yeah.
So since so here it's showing Vanakkam. So those kind of things. So next thing we'll be having is like ng build, how it will work. Normally what ng build will do is like it will build a package to us. Okay, I'm just building. So you could see I already built something, so it was there earlier. So if I build the default language, it just provided the packages. Normally what we will have like in the dist folder like it will have some files like this. Okay, so if I go to build process and mention configuration equal to French, we can side by side see the difference. What it basically provides, like it will we need to like build each and everything in a loop. Like if you have 5 languages, we need to build in a loop and get it done with this. We will have a folder like for French. Inside that, all the French related programs will be there. And if you have Tamil or another languages, we need to do those kind of builds. And using our own program, we need to switch between these folder based like deploying the application like a folder based thing on something like that in a different URL. So if you go to French, you will see the folders with various this thing, like the files we have. So let's come back to this thing. So right now, what you can actually using this Angular/localize is like if you have any static text or like even we known for a few languages, for example, if you have an application, it's having something like welcome, those kind of informations, and having a control like settings. If you want to show that settings words in a different language or different local thing, you can do those things. Even we could support various formats using different pipes which built on top of localization. So this is like one of the feature is getting developed as a part of Angular in upcoming versions. So we could eventually see a lot of improvements in the packages near future, and we will be having some locales like this. We'll be having some different variables and global variables, those kind of things, and we can use it across the application instead of sticking with ID. We will see these kind of static variables and IDs in the upcoming releases. So this is like one of the jumpstart kind of thing. We can get ahead and aware of something is coming as a part of Angular itself. We don't have to really depend on third-party application or npm plugins all the time. So if you could see npm JS, okay, I will search for Angular fresh localize. Even though package is not that much popular, but people still using we can see weekly download is already crossed 2 lakhs this thing. So when you go to Angular translate, so this is one of the common thing for popularly used application for Angular JS here. So when we see the build system of this Angular localize, like you see the last published app was like 2 days ago. So they are working on it aggressively and they are releasing various versions really. So we could see like 11.0 next was released 2 days ago, and we could see like a constant contribution has been made in this project. As I said earlier, like in the Angular 9 only it was get started. So they are maintaining the version number from the startup similar to Angular version. So it was like a 1-year-old package only, and it is getting constant contribution. So we could possibly see a lot of various interesting stuffs in the near future. So what I will do is now I have this package like the example I showed in the GitHub. In my so I'll share the link. So I'll type localize. Okay, here it is. So what you can try out this, like you can just check out this package. Basically, it will present inside this folder. You need to traverse inside it, and you can see this So where is the chatbots? Okay, here it is. So first one is your, so you could see the packages here. Next one is how to do internationalization with Angular. I'm not sure whether my blog will show up here. Maybe I'll show my company blog. Yeah. Whatever I had talked today, it will be present in a step-by-step manner. And even I had mentioned like what's the version I had used and the documentation links for this thing and the sample methodologies to run here. And even I had mentioned like my node package version, npm version in this blog. You can check out if you're interested. Of course, you can leave comments or doubts in this chat box basically. Or if you really want to get in touch with me in Twitter or anything, you could, okay, let me show like this so it will look fancy. So basically, my personal blog is like efficientuser.com, and I have all this information there as well. Like even I have some different blogs based on it, like the Angular, Bootstrap, Angular tutorial kind of things. So if you're interested, you can check it. Even that internationalization blog should be found here. I'm not sure. Okay, here it is. So here it will be like a little bit, you will be good. You could take a look. And of course, you can take a look at here to reach me out on Twitter. I just mentioned all the Twitter handle I have here. So it is efficientuser.com/about. So those are the things I have today to share with you guys. If you have any doubts, you can unmute or leave a chat so that we will be trying to answer if you answer.
Guys, any questions for Pandian? Okay, in that case, I think everyone is again
we can take it
so
as
busy processing your inputs. But actually, nice talk, Pandian. So it has been really missing piece in Angular framework for a while, especially in our, in our product. We have been really,
Yeah, of course. Like in one of our popular product in Coimbatore, like we started doing localization recently, but we had Angular 9 that time itself when we were trying to do this feature. But since Angular is not providing all the supports right now, we just gone with our own implementation. Anyway, in future, maybe we will be picking up this package and take a look for further improvements. So this is like, as you said, this is one of the missing feature or like missed piece of great work in the past. Like in Angular 9, they have provided a lot of different packages like copy to clipboard, YouTube player, those kind of things. So they are eventually adding the missing pieces now. So it's great.
yeah, eventually this also has to be improved a lot. But yeah, we hope they'll refine this very soon. I think long way to go. Cool. So Pandian, I would encourage, if nobody has any other question for you, I would encourage if you can come, everyone come video, probably we can take a quick snapshot and let Pandian enjoy his rest of the Saturday.
Okay, let me start my video. Okay, yeah, it's just
Everyone? It's really so hard to ask people around to enable their video on Saturday morning. Yeah, I guess.
okay. Yeah, it was,
yeah, no problem. Yeah, yeah, I'll just take a snap. Yeah, that works. Yeah, once again, thank you so much for your talk today, Content. I think it's been a long,
Sure.
long due, right? So we have been almost 3 months, right?
I think Karthik and me was talking about this session like from the May month, I guess.
Yeah,
So
Pandian,
we
for the record, this is me, Karthik. Okay, I just used.
okay, it was showing Sarunan, so I was
Yeah,
confused.
we just used one of
So,
our colleagues' login for Zoom. My bad. Anyways,
okay.
yeah, it was me, the one who tortured you over all the weekends and everything.
Okay.
Cool.
Nice.
So, and as I said, like, it was really it was really lovely to have you around. So we would appreciate for your time today with us, and also we would like to, have a few more sessions. We would like to host you, and of course, we are after all in Coimbatore, right? We are supposed to have these meetups very often. I would like to see you very often then. Okay.
Yeah, sure.
Yeah, thanks everyone. Sorry, thanks Pandyan. I hope we have our next speaker with us now.
Sure. Thank you.
Yeah, thanks Pandyan. So maybe we'll move on. I'm so sorry, everyone. I think before moving on to the next session, I would like to confirm once again. So you guys had any difficulties in registering this meetup today? Because I saw the count was dropped drastically, like drastically. So how was the experience with respect to registering in Zoom meeting, this meeting? Anyone? Surinder, Ramesh, Arun, Santosh?
It was quite easy actually. I mean, I have been using Zoom for a while, so it was pretty easy for me. Just the username, I mean, the first name, last name, and the uh, email address. Yeah, it was pretty easy.
Okay.
But also I saw the Telegram link that helped me a lot.
Okay. Yeah.
Telegram has a good touch to that. Yeah.
Yeah. Thanks, Surinder. Let me, in the usual feedback form, right? We used to send out. I'll also add this point as well. I'm not sure why. Maybe it's a Saturday. They didn't people. Had a time or something, but yeah, because I think the sessions were really good from the morning. I don't want people to miss such a great session. So anyway, we are recording all these sessions and we can host it in our YouTube channel as well. Awesome. So shall we get started for the next session, or do we guys need any 5 minutes, 2 minutes break through Vicky, Arun?
The speaker is ready. We could continue. Yeah.
Okay. Hi, Aristides.
Hello.
Sure. Yeah, how are you?
I'm fine, thanks. How about you?
Yeah, I'm good too. Let me enable my video. Hi there. Yeah. So, can you hear us properly, right?
Yeah, no problem.
Okay. Yeah, but we kind of sense an echo from your side. I'm not sure. What is it? So, what is your time now?
Here it's 9:30 in the morning.
Okay.
Early, you know.
Yeah, very early for a Saturday morning. Yeah, and I'm extremely so happy that you decided to spend your morning with us, and I really appreciate that. And so guys, without further ado, over to Aristides. If I'm not, I hope I'm pronouncing your name right.
You can call me Aris if you want,
Aris.
because it's
Yeah,
Aris.
Arist. Okay.
Can you hear me well? Because you said something about an echo.
Yeah. Guys, anyone else hear him well? It's just me.
I think it's okay,
I
Karthi.
I think it's fine.
okay for
It's fine.
us. Yeah.
Sorry, I was on mute. So I just made you, Aris, I just made you as a host. You can start sharing your screen. Then maybe we'll get started with the session. Okay.
Okay, thank you very much.
I think you have put a host for a Ramesh. You need to change Karthi.
Yeah. Oops. Just give me a second. Yeah. Done now.
Yeah.
So guys, please welcome Aris. So he's from all the way from Greece, and if I'm not wrong.
Greece.
Greece, yeah.
Greece, yes. Greece and
Yeah.
Athens.
Yeah. Yeah, thanks to Twitter and COVID, we are able to reach out to you guys, and you guys being very generous and willing to share your knowledge with us today. Yeah. So can you able to share your screen, Aris?
Yeah. Yeah, sure.
Okay. So guys, can you see his screen? Yeah, now we are good. Okay, over to you. Please go ahead.
Okay. So, hello everyone. Thanks very much. I'm very happy to be here, even in this Saturday morning. My name is Aristides Bampakos, but you can call me Aris because I'm from Greece, from Athens. Athens is the capital of Greece. So my name is Greek, and it's a bit difficult to pronounce when you are not Greek. Today, I'm very happy that I will talk about, for such an interesting but also an unusual topic in the front-end web development. Today, we're going to see how to build desktop applications using web technologies. And when we say web, we mean HTML, CSS, and JavaScript. More specifically, we're going to see how to integrate two awesome JavaScript frameworks, Angular and Electron, to create an awesome desktop application. So some things about me. I'm a co-organizer of an Angular meetup here in Greece, which is called Angular Athens, and I work as a front-end web developer at Plexearth, where I'm specialized in Angular development. I also work as a contractor at a private educational institute called Code Hub, where we teach the Angular framework in other developers and individuals. I'm an active contributor in the GitHub open source community, and my two main focus areas are Angular-based libraries and projects. I am an occasional contributor to the Angular.io documentation, and also I'm very interested in 3D maps and geospatial libraries. When I'm not coding, I maintain my own blog at Medium, where I mostly always write about Angular. And this month, my first book that I wrote ever was published. It is called Learning Angular, and it is destined for beginners. It shows you and it explains you how to create an Angular application from scratch and deploy it to a hosting provider. It goes you through all the process from scaffolding the application using the Angular CLI, applying some features such as forms, HTTP, routing, and finally it explains you how to deploy a ready-made application to a hosting provider. I have put the links in the slides if anyone is interested.
Yeah, you can post that links in the chats. That should be fine. Yeah.
Sorry?
You can post that links in a chat. Maybe they can use it.
Okay.
Yeah.
Shall I post it later or?
Yeah. Later after this. So probably in the meetup page, so that it will be there forever, so people can access it whenever they want.
Thanks. So, as I told you, I'm a front-end web developer. I work at Plexearth. Plexearth is actually the product of a company called Plexscape. It is the first ever hybrid desktop cloud-based software that was created for the architecture, engineering, and construction industry. It works with all major CAD software like AutoCAD, and it works as a plugin and enables engineers and civil engineers and architects all around the world to visualize their 3D projects, their houses, the things that they build in the real world. For example, in Google Earth or some other map provider. So in this image, you can see Plex Earth, how it looks like inside the AutoCAD platform. So one of the main features of Plex Earth is that you can import satellite images inside a CAD software. For those that don't know, a CAD software is software that civil engineers and architects use to build their projects or their buildings, houses, cars, and stuff like that. One of the most popular of such AutoCAD software, of such CAD software is the AutoCAD software, which is built from Autodesk. So Plex Earth mainly cooperates with AutoCAD, but it can support other CAD software as well. So one of the main features is that it can import satellite images inside this CAD software. It has 3 unique ways to accomplish this task. The first one is using a core mapping provider, such as Digital Globe or Hexagon. These core providers have their own satellites or small airplanes, and they can take their own satellite images. The second way is using an intermediate provider, such as Google Maps and Bing Maps. Now, usually these providers they don't have their own satellites or any other means to take satellite images, but they use the core providers above to buy the images from them. The third way is using a custom proprietary software that we built here in Plex Earth, which is called Map Explorer. Map Explorer is an application that allows you, a desktop application that allows you to create your own custom maps using all the above providers. It is built with Angular and Electron. So now I would like to show you a video how Plex Earth and Map Explorer can cooperate each other to import satellite images inside AutoCAD. But before I start, I want to give you a glimpse of how we visualize maps in Plex Earth. So suppose that you want to create a map of the United States that displays each state with a different color, different background color. So what would you do? You would create a map that consists of 3 layers. The first layer, which is the bottom one, and we call it base map, would take all over the world. So think of it like a Google Maps or a Bing Maps layer. On top of that, we would put another layer that displays only the United States, not all the world, and their borders. And on top of that, we would put the actual layer that we want to display, the United States, again, but with different background colors. So you can imagine that a map is like putting some slides overlay some slides onto a projector to display something on a remote screen. So let me show you the video now. Uh-oh. Sorry about that. Okay, let me adjust the playback speed. Okay, it's okay. So here you can see the environment of AutoCAD. Now, bear in mind that Map Explorer is a desktop application. It is built with Angular and Electron. Now, for the front end, we have used Angular and Angular Material for the user interface. And for the back end, we have used Electron. So front end is only Angular and back end is only Electron. So let's go. We are here inside the AutoCAD environment. We select Map Explorer. Now we open Map Explorer and we can see that there is already a base map. So we can put another map on top of it, another layer, which is called ESRI. ESRI is a very well-known map provider in the industry. So we will put another layer on top of that, which is the actual layer that we want to display, which is a railway network of a city. We select the layer. So here it is, the layer that we would like to display. It's the blue lines. We can toggle the visibility of some of the layers so that we can display what's going on. We close now Map Explorer. We return to the AutoCAD environment and we select the area that we want to import the map that we have created. Lexearth will start the process of downloading the map. And so here's the map that we have created. We have successfully imported the map inside the AutoCAD software. So we can continue building our project. So let's go back to our presentation. So what we will see today is we show how we use Angular and Electron inside Plexearth using Map Explorer. So we will see how to use similar techniques to create a single Angular application and convert it into a desktop one. So, as I told you, Map Explorer is an Angular and an Electron application. Angular, I think most of you that watch may know about Angular, but Electron is a really new player in town. So, what is Electron? It is a cross-platform JavaScript framework, and when we say cross-platform, we mean that it can run in many environments, and it allows us to create desktop applications using HTML, CSS, and JavaScript. It is actually an npm package, so we can install it with the user command and install. Now notice here that we use the -d parameter when installing it. We want to install it in the development dependencies because Electron is only used to build our application. It is not used during runtime. An Electron application is built on top of Chromium, Node.js, and the V8 engine of Chrome. An Electron executable actually contains a version of Node.js and Chromium embedded inside, and that is why Electron applications are very large in size. For example, you may think that Map Explorer is about 97 megabytes in total size, and 94 megabytes are only the runtime of the Electron framework. 3 megabytes are only our application assets. Now, the main advantage of an Electron application is that if you're a web developer, you can leverage your existing web skills and create desktop applications without the need to learn a new programming desktop language, for example, C# or C++. Many applications that we use in our everyday routine have been built with Electron, such as Visual Studio Code, which is the most popular one, Slack, WhatsApp, or even Skype. They have a pretty extensive list in their website, and it has applications that you couldn't even imagine that they were built with Electron. So let's see some things about the architecture of Electron. Now, an Electron application consists of two processes. The main process, which is responsible for making tasks that are heavy and need to make some difficult calculations. For example, when you want to interact with the file system, you will go through the main process. Now, this process also provides access to the native resources of your computer using the API of Node.js. The second process is the render process, which is responsible only for managing the user interface. Think of it as a single index.html file that contains all your application assets, CSS and JavaScript. So due to the nature that the Electron architecture follows the Chromium multi-process architecture. So in every Angular application, in every Electron application, you will have only one main process which can communicate with many render processes. But each of these render processes operates in complete isolation. If you want to communicate from one renderer to the other, you should go through the main process. There is a way to go directly, but it is not recommended. So how do we write an Electron application? As I told you, it's a JavaScript framework. So you obviously write JavaScript, but you can also write TypeScript. And you can transpile it later, as we will see in our example. So an Electron application, a minimal Electron application consists of one file, a main.js or a main.ts. Now, the minimal code that we need to create an Electron application is this one that you see in your screen. So we use the Electron npm package to import two artifacts: the app object, which we can think of it as the window object, the window object of a web page. This app is the global object of our application window. And then we also import the browser window that is used to create the renderer windows inside our application. So then we have a create window method that uses the browser window class to instantiate a new object, and it passes some properties such as width and height of the window. Browser window, the constructor of browser window supports a ton of properties. So you can go to the website electronjs.org and check them out. Now, after we have created the browser window, we use the method load file, and we pass an HTML file that we want to load inside this window. Now, opposed to this process, there's another way that instead of loading a single index, a single HTML file, you can load a URL and put inside here, for example, the URL of an Express Node.js server. This is a different approach. Now, in our case, we will pass an HTML file only. We will not use an embedded web server. So this HTML file, in our case, it will be our Angular HTML file that we will see later on. So as soon as we have created the window, the function that creates the window, we then call the when-ready method of the application object, which is a promise. And when that promise resolves, we then create the window. So an app object can have, we follow this approach because we want to make sure that we can create the window only when the app, the whole application is ready. So there is a way to create multiple windows on a single app. I know that for sure, but I haven't done it myself. I haven't yet done it myself. So this is the minimal code. Now, there are some considerations that you may encounter when you develop an Electron application, especially with Angular. These considerations we have also met these considerations during development with Map Explorer. So, what are these? The first one is that you may want to have a single code base for different users and environments. What do I mean with that? In our case, in Map Explorer, we wanted to have the same code, the same Map Explorer, but for different environments. Imagine that you are a civil engineer and you're sitting in front of your desk and using AutoCAD, and you want to import a map. So what would you do? We would open the desktop version of Map Explorer and import a map inside AutoCAD. Now, this map could have maybe been created from another user, maybe from an administrator, using another interface, another environment of Map Explorer, maybe from a web interface. So we wanted to have this collaboration between different environments and different users. The second consideration is that maybe you want to keep the user data locally, as we did in Map Explorer. And this is the reason that we say that Map Explorer is not we don't just render a web application inside the Electron. We do more than that. Our backend API is the Electron. I mean, we keep all user data in the file system using JSON format. So we can say that our application is a bit serverless. And there are some things that you need to consider there if you want to interact with the file system. For example, what library you will use, what approach you will take for saving the files and stuff like that. And the third and the most challenging one is how to communicate with an Electron application. For example, suppose that you have a desktop application, C#.NET application, and you also develop an Electron application and you want to communicate each other. Now, I can tell you that this process is very difficult to achieve. I mean, there are some ways out there in the web that you can check out, but they're not so reliable. So in our case, because PlexEarth and Map Explorer are different executable applications, we decided to go with file handling, using files. So we didn't find a solution that satisfied us. So these are some considerations that you may encounter during development in an Electron application. Another consideration that you have to make early, a decision that you have to make early when developing with Electron, is how to communicate with the main and the render process. Now, there is an object which is called remote object, and it is exposed from the main process using the global variable. So the main process can attach some global variables in this global object. For example, it can attach the FS library. The FS is a library for file system handling in Node.js. And later, the render process can access this global object and use the object that it has been exposed from the main process. For example, the renderer can import Electron, it can access the remote object and use the method getGlobal to get the exposed variable from the main process. Now, in this situation, we're actually exposing the FS library, and then the renderer can use this FS library, right? So we're actually exposing our file system to the render process. But I have already told you that the render process is a web page. So we're actually exposing our file system to a web page. Is it secure? I mean, is it right? Of course it's not. we all know that with exposing your file system to web pages is very dangerous and has many security problems. So you shouldn't do this. You shouldn't follow the remote object. There is also, at the end of the links, at the end of the slides, I have put some links, resources about my talk, and there is a link that discuss, there is an article in from medium.com that discuss why remote is considered harmful. In this, okay, let's continue. How do we disable it, the remote object? So luckily for us, the browser window class has a property called enable remote module inside the web preferences options that we can set to false to disable the remote object. So if you use Electron and you use a remote object, I would suggest to set this property to false. In the latest version of Electron, Electron 10, this property is set to false by default. Now, as I told you, the render process is actually a web page. So an Electron application in reality is a web application, and it has all the security problems and considerations that all web applications have. So you must be very, careful of what you do with your Electron application. If you want to learn more about security and Electron applications, you can check out this podcast, this guest podcast that I did with Real Talk JavaScript, where I talked about how to build secure Electron applications. I have put the link in the slides, and I will put it also in the chat later on. Excuse me. So, if we can't use the remote object, what can we do? We can use a technique called IPC communication. IPC is a technique for exchanging messages between the main and the render process asynchronously. Now, the previous technique that I showed you, the remote object technique, was synchronous. This one is asynchronous. And how do we use it? In the main process, we use an object called IPC main, and specifically, we use a method handle to attach, to add an event to the main process. So essentially, the handle method is like the add event listener of the JavaScript. The handle method takes two parameters. The first one is the name of the event, which should be unique. And the second one is an arrow function that is executed when someone calls this getData event. Now, the renderer process can import the Electron object and it has access to a similar object to the IPC main, which is called IPC renderer. It can then use the invoke method of the renderer to call the getData event. If we want to pass arbitrary data to the main process, to the event, we can use the second parameter of the invoke method. So let's see some code now. Now, here is an Angular application, the typical Angular CLI application. You can recognize that from the file structure on the Solution Explorer. There are some other files that exist here, such as Webpack configuration, but we will see what are these later on. So I have created an Angular CLI application, pretty simple. Let's run it. I have a very nice Visual Studio extension that I use for my daily web development routine, which is called NX Console. NX Console is made from the Narwhal team, and it provides a wrapper over some Angular CLI commands. For example, you can build your application, you can test it, and you can serve it. Now, we're interested in the serve, so we select serve. We select the project that we want to serve. We can pass some additional parameters. Now, please notice that this serve is the ordinary ng serve command that we use from the command line of the Angular CLI. We can set some additional parameters. In this case, we don't want any additional parameters, so we click run. And when we click run, you can see that it runs ngserve and tries to compile our application. So let's view that on our browser. Okay, you can see from the style that I have left most of the CSS of the skeleton application that Angular CLI creates. The header is the same, so you can recognize it. The difference is that I have created a list here of pirate names. Pirate, I choose pirate because I'm a fan of Assassin's Creed and especially of Black Flag. So you can see behind me a lot of Black Flag Assassin's Creed stuff. So I have put a list of these pirate names. So let's see how we could take this application and render it as a desktop one using Electron. If we go to the Solution Explorer, inside the source folder, there are two folders that we need to pay attention. The first one is the app folder, which contains the Angular code that I show you right now. The second one is the Electron folder that contains only Electron code. So we have put them separately so that we can handle them more easily. Inside the Electron, we have the main.ts that I showed you before. It has the imports, the create window function, and the app when ready. Nothing special. I showed to you before. So how do we run this Electron application? If we go to the package.json, now at this point, before showing the package.json, I want you to pay attention to this one. Now this index.html file is the main HTML file of our Angular application. So essentially, in this approach that I show you, we're building, we build the Electron application, we transpile it because it is a TypeScript file. So we will use Webpack, as you will see later. We transpile it and put the output file inside the same dist folder that Angular CLI puts the output file of the Angular application, of the Angular code. Okay. So if we go to the package.json scripts, you can see here that we have a script called start Electron. Now this one, what it does, it starts at the same time the build of the Angular code and the Electron code. For the Angular code, we use the ng-build and we pass a specific Electron environment, Electron configuration, and you can see here that we don't delete the output path because we will also put the Electron code inside the same path. After we have built it in watch mode, we compile the Electron code using Webpack and a custom Webpack configuration. Sorry about that. Oops. And a custom Webpack configuration. In watch mode, again. So if we run the script, you can see here that it will first build the Electron code and it will output it as a shell.js file. And then the build of the Angular code continues. Okay, now that the Angular code has finished, we can go to the debug mode, to the run mode of Visual Studio Code. I have created a debug configuration here to start the Electron. So if I click it, we can see the same Angular application that we saw before, but inside a desktop window. Now, this the Angular application is rendered inside a Chromium window. This one is Chrome. You can verify this if you go to the View menu, toggle Developer Tools, and you can see that it has all the same features of Chrome Developer Tools. It has console, it has the network tab, the elements that you can inspect. Just ordinary, it is as an ordinary web page. So, if we go to the dist folder now, we can see that it contains all the Angular files that the Angular CLI creates, the main.js, for example, but you can see also the cell.js, which is the Electron code. It is in the same folder, so that the cell.js can recognize the index.html and load it. Now obviously we named the main.ts of Electron as cell.js so that we don't have any conflict with the main.js of Angular. So when I run ngserve, let me run ngserve again. All right. So if we go here and go to the network tab, okay. If I refresh it, you can see that the pirates folder, the pirates name, sorry, are fetched from a pirates.json file, which is inside the assets folder. So we're using HTTP client to fetch the pirates.json and display the contents on the page. So if we go to the source folder, into the app, you can see that there is a pirate service that uses the HTTP client and issues a GET request to the assets pirates.json file, and it also converts it to a promise using the toPromise operator, ArcJS operator, so that we can later in the component use async await syntax. Okay. So we use the getPirates method. We call the getPirates method from the service that I showed you before inside the engine init. Nothing special. This is pretty common in an Angular application. Now, in the Electron application, let me start it again. Okay. If I go to the network tab, if I make a reload, you can see that there is no HTTP request involved. So how all these pirate names, from which source did they come from? Actually, we don't make an HTTP request, as you saw, but instead we let Electron, we make Electron to read it from the local file system as an ordinary file. So if we go to the main.ts of Electron, you can see that we use the IPC communication technique to add an event listener using the handle method. The method is called getPirates. So when someone calls getPirates, we use the FS library and we read the file assets pirate.json from the file system, and we parse it as JSON so that we can return it. So there's no HTTP client involved here. Now this getPirates is called from the Angular code inside this pirate local service. You can see here that this service has the same signature, the same methods as the previous pirate service, but instead it doesn't use the HTTP client, it uses an Electron service class. It can access the IPC renderer and it can invoke the getPirates method. So this call goes to the main.ts here and returns the names of the pirates without using HTTP. Now here you can see also that the Electron service is part of a library that we use, which is called ngx Electron, and it is a library, it is a wrapper library for the Electron window, for the Electron object. So that's okay, Aris, but how can our application understand which service should it call? Inside the app module, we have inside the providers array, we have used the object literal syntax to replace the pirate service accordingly. So when someone asks for the pirate service, we don't return one of the two services, but instead we use a factory, a pirate factory. Now this factory checks the desktop property of the environment object, and when we are not in desktop, and it means we are in the web, we create a pirate service and we pass the HTTP dependency. Now, if this desktop is true, this means that we are in the Electron world, in the desktop world, and so we return an instance of a pirate local service, and we inject the Electron dependency. So we have used the dependency injection mechanism of Angular to replace our pirate service accordingly, according to the environment that we are operating. Okay, this environment.desktop, if you go to the environments folder, oops, sorry. You can see we have one additional environment, except the default one, which is the environment.electron. Now this one has a property desktop equal to true. The two other environments have desktop equal to false. So when we build the application inside the package.json, we pass the appropriate configuration. Now, since we create our application, we developed it. So let's build it now for production. There is another script inside package.json, which is called build electron. Now, this script makes the same work as the start electron, but instead it builds for production. First, we run ng-build, again with the electron configuration, and we pass some additional production-based CLI parameters. And then we also use Webpack to build the Electron code, and we pass a different Webpack configuration. You can see on the Solution Explorer that we have two different configurations, Webpack configurations, for each environment, either development or production. Now let's run it. First, it runs the Angular application. It compiles it. right? Angular has finished, and then it compiles the Electron code. Now you can see here that now we don't use cell.js, we use main.js, because now the main.js of the Angular is not main.js, it has a hash inside the file name. If you go to this folder, you can see that this main.js is the Electron now, and this main.something.js is the Angular now. So we don't need to, we will not have any conflict with the file name. So we put main.ts as of the Electron code as main.js. Now we build it for production. The last step of this demo is to package it and make it an Electron application. So we have another script here, which is called package, and it uses a library called Angular-Packager. This library allows you to build a web application, to package your application for the three major operating systems, Windows, Linux, and Mac. So if we go to the dist folder now, we can see that we have two folders, one additional folder. The second one contains the name of the operating system that we told the packager to build. If we open this one, now you can see here is the executable file. Here is our actual application. This one is, if you go to properties, you can see that it is 105 megabytes in size. Now, this 105 megabytes is only the Angular runtime. Our application code is not inside this executable. This executable is very large, as I said at the start of the beginning, because it contains a version of Node.js and Chromium inside embedded. Our application resides inside the resources folder, and it is this file called app.asr. Asr is a zip format for Electron applications. You can open it using an ordinary zip client. Now, if you see, you can see that the size of this ASR is 189 kilobytes. I mean, the difference is very large between the executable of Electron and our application code. So, one last tip for your development is that here we have the browser lists RC file. Now, since we are building for Electron and Electron is Chromium, we can remove all content that is not Chromium related. Okay, so I would suggest if your application, and if you want to create an application that operates in web and in desktop mode at the same time, not at the same time, if you create two separate builds, one for web and one for desktop, then I would suggest to have two different browser lists RC files, one using only the Chrome and another one using the full set of versions of browsers, because your application, your web application, you would like to operate in all browsers. So on the last slides, I have put my communication links in case you want to check what I'm up to. I have also put the source code of the demo that I show you and some resources. Thanks very much. It was a pleasure to be here today and a real good experience. And I would like also to thank the Coimbatore, if I pronounce it correctly, Frontend group for accepting my talk.
Very well. Yeah. So it's our pleasure to host you, Aristides. So thank you so much for the awesome session as well. So I hope you will share these links in the meetup group.
Let me put my headphones on. Let me put my headphones on a bit.
Okay.
Okay, I can hear you.
Okay, so is it any better now?
Yeah, yeah.
Okay, awesome.
Yeah, you
So
know, when I'm not talking alone, I prefer to have my headphone on because it's better to listen.
yeah, definitely. So I was saying it is our pleasure to host you today, and that was really a great talk. And I think this is the first electron talk we ever had, if I'm not wrong. So I hope we'll find more interesting. I mean, we'll see few people start working on electron as well. Awesome.
Yeah, I hope after today, many of those people that will watch us, will start creating desktop applications.
Yeah, definitely. So thank you so much for your time with us, and have a great weekend. And please, one last reminder. So just please share these PPTs and whatever the links you have in the meetup page. I'll share you the link over Twitter as well. So guys, I think you can also reach out him through his Twitter link, which is already posted in the meetup description. So he's such a sweetie pie. He will answer all your questions. And I appreciate your time with us, Aristarchus, once again. And I really like your background.
Thank you very much thank you very much.
Yeah. Awesome. So guys, one last note before we wrap up for the day. So as I mentioned, the Coimbatore Frontend group is looking for volunteers across all the domain. So you need not to be very technical to contribute. You can help us with the speakers relationship and social media communications and all those things. Even you can also be the moderator for these events, and you can help us with the hosting events and everything. Okay. And that's one thing. And also you can use our Telegram group, which is very active in all the aspects. If you want to share feedback, if you want to say something, if you want to connect with people, if you have a job post, or if you're looking and what not, okay, the Telegram is much active. You can go and drop a text there, and we'll be in touch with you as soon as possible. And the last point but not least, we would like to thank our sponsor once again. So the JetBrains, who is actually sponsoring license to all the participants every month. I mean, not all the participants. So with 2 license per meetup every month. So this month, Rafael is being delayed because we have some, or one of our volunteer, or I mean, one of the organizer had some personal emergencies. We'll be in touch with you guys very soon. And the second thing, the second sponsor, Trustrace, who also happened to my employer, who is actually sponsoring this meetup in all the aspects. When we were on the face-to-face real meetup and everything, and also now even virtual, they are trying to push everything possible to keep us going. Okay. So with that note, I would like to close the call, and unless you guys have any questions or anything to discuss, maybe we can call it a day. And wish you all a happy weekend, and please stay safe and stay put. And yeah, that's it. Goodbye, guys. Thank you so much.